All right, so looking at section 3 of this chapter dealing with radicals, so we've looked at simplifying them and rationalizing the denominator, so now we're looking at adding, subtracting, and foiling, and something called a conjugate in this section, binomial radical expressions. And so what we're doing here is that we're taking an expression and we're going to be simplifying it to try to simplify it down to something that we can easily handle. So whenever you're adding or subtracting radicals, what you're looking at is you're looking at the radical itself. Okay, that's the first thing you want to identify. If the radical is the same for two different terms, and you're adding them, all you have to do is you just add the front part. So in this case, since the two radicals are exactly the same, the fourth root of 45 and the fourth root of 45, all we have to do is we just add 8 and 3. And that gets us an 11 fourth root of 45. Okay. So if the radical part is exactly the same, we add them together just like they were like terms. Just like if it was an x or a y or a variable, any other variable. So if they're the same, you add them together. Okay. So now let's look at this one. So the first one, can we combine these? It's square root x, y, square root x, y, same. Okay, exactly the same. So we can't add them together. And it would be negative 1 square root xy. Okay. Now let's look at the second one. The second one, we see 15 square root 7 plus 2 cube root 7. Well, since the index of these are different, or the root that we're taking them, since they are different, we cannot combine them. Okay. So since we can't combine them, we would leave it as is. It stays the same answer. Okay. So if the radical part are not the same of two separate terms, we cannot combine them. We leave them separate. Okay. Now multiplying. Now multiplying, whenever you have two groups that are being multiplied, you're going to FOIL, first, outer, inner, last. Okay. So here first, 3 times 4, 12. Outer, 3 times 3 root 11. That would be 9 root 11. 2 root 7 times 4, inner, which would be 8 root 7. And then last, which would be looks like 6 root 77. Remember, when we multiply two radicals together, we multiply the numbers on the inside. And then we'll see if we can combine terms from here. Well, since we can't, we would leave it as is. We can't combine anything, so it stays what it is written. Okay. All right. So now we look at the next one. Let's see here. 7 times 4, 28. 7 times root 6 would be 7 root 6. Negative root 6 times 4 would be a negative 4 root 6. And negative root 6 times negative root 6 would be negative root 36, which is 6. So now we can combine like terms. You see how the radicals are the same of these two? Root 6, so we can combine them, which would get you negative 3 root 6, and then 28 minus 6, which gets you 22. Okay. So you get 22 plus 3 root 6, and that would be your answer. So again, multiplying, you're just using FOIL, your first, outer, inner, last. Okay. Whenever you're multiplying these together. All right. And remember, multiplying or combining like terms, if the radicals are exactly the same, you can combine them. Now there's something called the conjugate. Now the conjugate is something that's kind of special. It gets rid of the radicals. Now we kind of dealt with this a little bit when we were dealing with complex numbers and imaginary numbers, getting rid of i's in the denominator. We can do this with radicals as well. What your conjugate is it's the exact same numbers, it's just the signs changed. So as you see, it's 4 minus 7 root 2. The conjugate of that would be 4 plus. Okay. The big thing here is the sign changes. Everything else stays the same. Now when we multiply these together, okay, when we multiply these together, we get 16 minus 28 root 2 plus 28 root 2, 28 root 2. And then it would be minus 49 times the square root of 4, which is 2. And see, as you see, we get rid of our radical, which is what we're trying to do. And this middle part disappears. Negative 28 root 2 plus 28 root 2 is 0. So all we're left with is 16 minus 98. 98. Okay. 16 minus 98, which gets us a negative 82. Okay. And that's our answer. And so that's what the conjugate does, is it gets rid of our radicals so we don't have them. So what would be the conjugate of this one? It would be the conjugate of 5 minus root 7 or root 11 would be 5 plus square root 11. Now we multiply 5 times 5, 25. 5 times square root 11 would be 5 root 11. Negative root 11 times 5 would be a negative 5 root 11. Negative root 11 times root 11 would be a negative 11. Now we combine like terms. These disappear, leaving us with just 25 minus 11, which is 14. And that would be our answer. So see, that's what the conjugate does. It gets rid of our radicals for us. Now this is where the reason why we would use the conjugate. Rationalizing the denominator. And so we do not want a radical in the denominator. You know, it's what we've done previously. But as you see here, we have something added or subtracted to that radical. So what we're going to do is we're going to multiply what's called a trivial 1, and it's the conjugate over the conjugate. Okay. So as you see, this fraction right here is just 1. It's the same thing over the same thing. And we're going to multiply to it. Well, the reason for this is because it's going to get rid of our denominator. And then from here, we're just going to FOIL. Okay. You would just FOIL it through, which would get you 24 plus 10 root 15 plus 15 all over 16 minus 15. And again, this is just multiplying, FOILing everything through. And then you simplify it down, which gets us a 39 plus 10 root 15 all over 1, or just the top part. Okay. As you see, what the conjugate does is it helps us rationalize it. So here we would multiply this one by 1 minus root 3 all over 1 minus root 3. And the second one, we would multiply it by 2 plus root 3, 2 plus root 3. And then again, we would distribute, or we would FOIL these through. Okay. And it looks like this top one's going to get us a 4 minus 4 root 3 all over 1 minus, would be what, negative 2. And then that reduces down. And then the second one would get us 13. So as you see, what happens is sometimes we'll get rid of the fraction, but we're not having the radical in the denominator, which is the key thing for this. All right, your IRAT, the first one, multiply, so FOIL this top one through, so FOIL it. And then the bottom one, rationalize the fraction so you do not have this radical on the bottom. So multiply by its conjugate. Okay.